Several codes and standards address the necessity and frequency of infrared, often called IR, testing. NFPA 70E, Standard for Electrical Safety in the Workplace, Section 130.7. C11 requires IR scanning to be performed on electrical equipment where accessible energized conductors or circuit parts are likely to fail due to age, damage, or other factors. Section 130.7. D requires IR scanning of electrical equipment at least once every 3 years. ASTM E2360, Standard Practice for Infrared Imaging of Electrical and Mechanical Systems, Section 7.6 recommends IR scanning of electrical equipment at least once per year for critical systems and at least twice per year for non-critical systems. The American Society of Heating, Refrigerating and Air Conditioning Engineers, known as ASHRAE Handbook of Fundamentals, states that IR scanning of electrical equipment is highly recommended at least once every 2 years. The International Organization for Standardization, known as ISO ISO 18434-1.2018 provides guidance on the use of IR thermography in electrical installations. It recommends that IR scanning be performed on electrical equipment at least once every 3 years, and more frequently for equipment in harsh environments or under heavy load. The National Electrical Code, called the NEC, does not specifically require IR scanning, but it recognizes the value of predictive maintenance techniques, including IR scanning. The Institute of Electrical and Electronics Engineers, known as IEE, has published several standards related to IR scanning of electrical equipment. Several factors should be considered. The frequency of IR scanning may vary based on several factors. Firstly, the type of equipment. Secondly, the age of equipment. Thirdly, the environmental conditions. Fourthly, the maintenance history. Fifthly, the criticality of the system. It is important to consult with a qualified electrical contractor or engineer to determine the appropriate frequency of IR scanning for your specific electrical system. Infrared thermography is a non-destructive testing method used to detect temperature differences in electrical and mechanical systems. These temperature differences can indicate potential problems, such as loose connections, overloaded circuits, insulation breakdown, and bearing failure. By identifying these problems early, infrared thermography can help prevent equipment failure, reduce downtime, and improve safety. In electrical systems, infrared thermography can be used to inspect a variety of components, including switchgear, transformers, circuit breakers, fuses, and wiring. In mechanical systems, it can be used to inspect motors, pumps, bearings, and heat exchangers. The frequency of infrared testing depends on several factors, including the type of equipment, its age, its operating environment, and its criticality. For critical equipment, such as that used in hospitals or data centers, infrared testing should be performed more frequently than for non-critical equipment. It is also important to consider the maintenance history of the equipment. If equipment has a history of problems, it should be inspected more frequently. Infrared testing should be performed by qualified personnel who have been trained in the use of infrared cameras and the interpretation of thermal images. The results of infrared testing should be documented and used to develop a maintenance plan. Infrared testing can be a valuable tool for preventing equipment failure and improving safety. By identifying potential problems early, it can help to reduce downtime and extend the life of equipment. Here are some additional benefits of infrared testing. Firstly, improved safety. Infrared testing can help to identify potential electrical hazards such as overloaded circuits and loose connections. Secondly, reduced downtime. By identifying potential problems early, infrared testing can help to prevent equipment failure and reduce downtime. Thirdly, extended equipment life. By identifying and correcting problems early, infrared testing can help to extend the life of equipment. Fourthly, improved energy efficiency. Infrared testing can help to identify energy losses, such as those caused by insulation breakdown. Fifthly, reduced insurance costs. Some insurance companies offer discounts to companies that perform regular infrared testing. Infrared testing is a valuable tool for any organization that relies on electrical or mechanical equipment. By identifying potential problems early, it can help to prevent equipment failure, reduce downtime, improve safety, and save money. When considering the frequency of infrared testing, one must weigh the costs against the benefits. More frequent testing provides more opportunities to identify potential problems before they lead to failures, but it also incurs higher costs. Less frequent testing reduces costs but increases the risk of overlooking problems that could lead to costly breakdowns. A comprehensive infrared testing program should include a written plan that outlines the scope of the program, the frequency of testing, the procedures to be followed, and the qualifications of the personnel performing the testing. The plan should be reviewed and updated periodically to ensure that it remains effective. The selection of equipment to be included in the infrared testing program should be based on its criticality and its potential for failure. Critical equipment should be tested more frequently than non-critical equipment. Equipment that is subject to high stress, vibration, or temperature should also be tested more frequently. The frequency of infrared testing should also be adjusted based on the results of previous tests. If previous tests have revealed problems, the equipment should be tested more frequently until the problems have been resolved. It is also important to consider the environmental conditions in which the equipment operates. Equipment that operates in harsh environments should be tested more frequently than equipment that operates in clean environments. For instance, equipment in a dusty or humid environment is more likely to experience corrosion or insulation breakdown, necessitating more frequent inspections. The specific standards and guidelines mentioned previously, such as NFPA 70E, ASTM E2360, ASHRAE, and ISO 18434-1.2018, offer detailed recommendations for different types of equipment and operating conditions. These standards should be consulted when developing an infrared testing program. Furthermore, consider the type of electrical loads the system carries. Systems with consistently high loads or frequent load fluctuations are more prone to overheating and should be monitored more closely. The skill and experience of the thermographer are also crucial factors. A qualified thermographer can accurately interpret thermal images and identify potential problems that might be missed by someone with less experience. Regular training and certification are essential for thermographers to stay up to date with the latest techniques and technologies. Documentation is a key aspect of any infrared testing program. Thermal images, along with detailed descriptions of any anomalies detected, should be recorded and maintained for future reference. This documentation can be used to track the condition of equipment over time and to identify trends that may indicate developing problems. It is also important to establish clear criteria for determining when corrective action is required. Temperature thresholds can be established for different types of equipment, and any readings that exceed these thresholds should trigger an investigation and prompt repairs. Corrective action should be documented, and follow-up infrared testing should be performed to verify that the repairs have been effective. The integration of infrared testing with other maintenance practices can further enhance the effectiveness of a comprehensive maintenance program. For example, vibration analysis can be used to detect mechanical problems in rotating equipment, and oil analysis can be used to assess the condition of lubricants. Combining these techniques can provide a more complete picture of the overall health of the equipment. Finally, it is important to remember that infrared testing is just one tool in a comprehensive maintenance program. It should not be used as a substitute for other preventive maintenance practices such as regular cleaning, lubrication, and visual inspections. The most effective maintenance programs combine a variety of techniques to ensure that equipment is operating safely and reliably. In review, establishing a well-defined infrared testing program involves firstly consulting relevant standards and guidelines to determine appropriate testing frequencies. Secondly, considering the type of equipment, its age, operating environment, and criticality. Thirdly, employing qualified thermographers with adequate training and certification. Fourthly, documenting all test results and corrective actions. Fifthly, integrating infrared testing with other maintenance practices. By carefully considering these factors, organizations can develop effective infrared testing programs that help to prevent equipment failure, reduce downtime, improve safety, and save money. Always prioritize safety when performing infrared testing. Ensure that all electrical equipment is properly de-energized before any inspections are carried out unless live testing is specifically required and performed by qualified personnel with appropriate personal protective equipment. This is a critical aspect to ensure the safety of the thermographer and prevent electrical hazards. Moreover, be aware of potential arc flash hazards and follow all applicable safety procedures. Proper training in electrical safety and the use of personal protective equipment is essential for anyone involved in infrared testing of electrical equipment. In some cases, it may be necessary to use remote viewing techniques to inspect equipment that is located in hazardous or inaccessible areas. These techniques can involve the use of drones, robotic crawlers, or other specialized equipment. When using remote viewing techniques, it is important to ensure that the equipment is properly calibrated and that the images are clear and accurate. It is also important to have a clear communication protocol in place between the thermographer and the personnel operating the remote viewing equipment. The interpretation of thermal images requires a thorough understanding of heat transfer principles. Factors such as emissivity, reflectivity, and ambient temperature can affect the accuracy of temperature measurements. It is important to use appropriate techniques to compensate for these factors and to ensure that the thermal images are accurately interpreted. Many infrared cameras have built-in features that can help to correct for these factors, but it is important to understand how these features work and to use them properly. In conclusion, implementing a comprehensive and effective infrared testing program requires careful planning, skilled personnel, and a commitment to safety. By following the guidelines outlined above, organizations can maximize the benefits of infrared testing and ensure the safe and reliable operation of their electrical and mechanical equipment. Remember to regularly review and update the infrared testing program to reflect changes in equipment, operating conditions, and industry best practices. This ongoing effort will help to ensure that the program remains effective and that potential problems are identified and addressed in a timely manner. Additionally, consider the use of software and data management tools to streamline the infrared testing process and to facilitate the analysis and reporting of test results. These tools can help to automate tasks such as image processing, temperature analysis, and report generation. They can also provide valuable insights into the condition of equipment over time. The benefits of a proactive approach to infrared testing far outweigh the costs. By investing in a well-designed and properly implemented infrared testing program, organizations can protect their assets, reduce downtime, improve safety, and save money in the long run. Infrared thermography is a powerful tool that can help to ensure the reliability and efficiency of electrical and mechanical systems. Organizations need to understand that a successful infrared testing program is not a one-time event, but rather an ongoing process that requires commitment, training, and continuous improvement.